everyone. Here we are at Arizona Springtime, Memoir of a Journey. This is Chapter 10, The Gifts of Gardens. There are many theories about gardening in the desert. We have changed our vision of the landscape over time based on research and the practical knowledge we gained from it in our experiences. One type of desert garden is the pollinator garden. The Arizona Sonora Desert Museum follows a specific design process for gardens at their spacious property. Generally, their goal is to attract valuable pollinators such as bees, butterflies, moths, bats, and hummingbirds. The staff assigned to the planned gardens start with a theme to consider such variables as available monies and size. A site analysis considers such things as slope runoff, soil maintenance, public viewing, and screening for unwanted backgrounds, such as parking lots. Then they select the optimal site and define the concept based on their analysis. That results in a preliminary design including hardscapes as part of the equation and then a final design to scale. The team estimates the cost as they ready for implementing the plan along with a preparatory plan for maintenance. On the scene, they may have to refine the garden to deal with such issues as the seasons, colors, and timing of blossoms for certain species of pollinators. Because it is a public museum, they also have to take into consideration safety of their visitors, so placement of cactus has to be well thought out ahead of time. The museum finishes their responsible leadership by preferring native plants that utilize the mineral makeup of the desert soil more efficiently than exotic species. In our area of southeastern Arizona, among the common pollinators are migrating and seasonal hummingbirds. We use hummingbird feeders to provide a consistent availability of nectar so that the numbers of hummingbirds can increase beyond just the available native plants on our property. We are currently designing a property to add varieties of native plants that attract hummers and butterflies. Designing our plant garden to attract pollinators began with an inventory of all current hummingbird-friendly plants. In the Southwest, the right time of year to plant native plants and shrubs is during late fall and throughout the winter. Winter rains will benefit the plant's root system during that time of year. Hummingbirds are very territorial, and planting for the little fighters means the gardener may need to place shrubs and plants far apart rather than for convenience. We also needed to match the average low temperature and last frost date to tolerances for species of plant. Most available plants from nearby nurseries are specific to Tucson or the Sonoran Desert. Many of those are not tolerant of our extreme yearly temperature variation. A desert gardener should know that Mexican bush sage blooms in April and May, while Texas sage blooms from April to October and is frost sensitive, while the Mexican bush sage is tolerant of cold weather. These considerations are important to know in staggering blossom dates for maximum benefit to the hummers and other vital pollinators. Another type of garden is the traditional vegetable garden. Spring gardening has been part of human experience for thousands of years. On a global scale, it is an indication with interaction with the tilt of the Earth. The tilt formed billions of years ago after a large celestial body crashed into Earth. That accident from space has resulted in life adapting to changing climate, something that might not have otherwise existed. Spring is an Earth event. We looked for inspiration from the true native masters of desert gardening. The Tohono O'odham have been at it successfully for hundreds of years. The desert people prepare a charco that diverts rainwater into pools. The garden bed has raised sides and is prepared before the arrival of the late summer monsoon rains. They cultivate native varieties of vegetables, including corn, beans, squashes, and melons. The vegetables have domesticated to the point that the desert farmers will know if wild seeds have invaded their garden. The invaders don't have the desirable characteristics of the domesticated plants. The farmers put the blame for the indiscretion on coyote, the devilish prankster. The undesirable plants are named for the prankster. One example of many is coyote melon. After our first year of vegetable gardening, we consulted Sarah Stein through her book, Noah's Garden. Her lucid theory is that wildlife requires corridors for it to thrive in the world. As she began investigation into the theory, she contacted another gardener. He sent her a garden plan for his suburban tract home. His garden took into consideration the diversity of life. He included a meadow with sedges, grasses, and wildflowers. For more diversity, he built an artificial pond, a wetland for bog plants, and a hedgerow with plants to provide berries. He even found the space on his small lot to tuck in a corner a small woodland. His goal was to increase the biodiversity in a suburban cul-de-sac. She developed her own plans for her small suburban property with an eye to increase biodiversity. The day we arrived at our small rural town some 30 years ago, it was a pleasant early April spring day. We had left the Phoenix metropolitan area to live in a remote rural area of southeastern Arizona. We had already made plans for a garden that would include a wide variety of vegetables, herbs, and flowers. We planned on a large garden that we named the main garden, and would include 3 rows of corn, 3 rows of beans, 3 rows of peppers, 3 rows of tomatoes, and 1 row of eggplant. These main crops would be surrounded by onions, marigolds, nasturtiums, cornflowers, and loofah sponge, a squash. We planted seeds in consideration of the estimated time to germination and those that should be planted with summer rain, such as blue corn and temporary beans. The back garden would be planted for watermelon, zucchini, parsley, cilantro, radish, mustard greens, Roma tomatoes, and garlic, all surrounded by baby's breath. The porch garden under an overhang would have runoff from grain that fell from the western face of the pitched roof. There we planned for straw flowers, pole beans, chives, carrots, a slow-growth radish, and lettuce. In a small garden out the kitchen window, sunflowers would grow from runoff from that side of the roof. The garden plan took into consideration soil nutrient deficiency. We raked in nutrients prior to planting dates. We planned for success, but there were a couple of things we did not know. At our higher elevation, 4,200 feet, we had not known that the final spring frost could be any time during April or May. Neither did our fruit trees. There were various types of fruit trees already planted by the time we took over the property. Those included varieties of peaches, apples, and pear. Grapes, for Chardonnay wine, had also been planted on the property near to the house. One year, a severe late frost destroyed the fruit trees. Our hardy grapes survive to this day. An unexpected invasion of whiteflies, a familiar enemy of the gardener, was a result of the non-native insect hitching a ride on a seedling from the nursery. We watered the garden every day. Desert life reacts to the precious water, and a new habitat is born. Our gardens became home to a wide variety of desert life. Unfortunately, the whiteflies attacked several vegetables with dire results, but the flies were a feast for gnat catchers. We began to plant the main garden within 2 days of our arrival. We had not even unpacked most packing boxes before taking up the shovel and hoe. We began by planting varieties of tomato seedlings, including petite fruit early girls and heirloom yellow pear. Both became long-standing success stories. We also planted loofah sponge and a variety of peppers, including Anaheim, Big Jim, and jalapenos. We put in Chinese yard-long beans, black-eyed peas, California peas, Bisbee black beans, chamomile, and golden banta sweet corn. 10 days after the main garden was put in, we planted the porch garden. That included radish, hops vine, jackpot zucchini squash, beets, carrots, and purple coneflower. In the main garden, germination began 9 days after planting, with beans, cowpeas, and corn lifting tiny heads. We planted several types of beans, not only for food, but to aid the deficits in our soil. The story of the valuable beans starts with the element nitrogen and problems associated with it. botanists discovered that few plants take nitrogen directly from the air and are able to use it. Earth's atmosphere is full of nitrogen, and the element is tantamount for the success of plants. It is an essential ingredient of chlorophyll, which in turn is used by plants to process sunlight into usable sugars. The natural occurring element is also used in building the plant's amino acids. Without nitrogen, the plant cannot make amino acids and will weaken and die. It is analogous to building a sidewalk of concrete without gravel. Concrete is weaker without the addition of gravel. Plants have adapted to get nitrogen out of the soil, but still not enough to survive. Legumes, such as beans, have adapted to the deficit by building a commensal relationship with bacteria found naturally in soil. The beneficial bacterial colonies have been around for millions of years and live at the roots of plants. They naturally produce an enzyme that changes organic matter into ammonium, containing nitrogen and hydrogen. The plant is able to use the nitrogen in the ammonium for its own use. There is one problem with this scenario. The enzymes the bacteria produce die if exposed to oxygen in the air. Plants use an ancient remedy to address the problem. They produce globin, similar to hemoglobin found in human blood. The manufacturing of globin in organisms dates back to an ancient ancestor so old it lived before animals and plants had split on the tree of life. The vital globin will capture or fix oxygen molecules. That means the bacteria-produced enzymes can continue unabated in their valuable work for the plant. Beans are like the mechanics of the plant world. They fix things for everyone. In the first few days of May, I planted beargrass, closer to genetic relation to a yucca than grass. I first encountered a beargrass at Fort Bowie National Monument on the hill overlooking the Frontier Adobe Fort ruins. I was exploring the area for the same spot a photograph had been taken over 100 years ago. I carried a copy of the photograph and held it up to gauge how close I was to the exact location. Nearby were large tufts of what appeared to be very tall grass. I grabbed a blade and pulled. It sliced open my index finger along the serrated edge of the blade. I was surprised, and while my finger bled, I knew I would like that type of tough, desert-adapted plant in our garden. Only a few days later, at a nearby nursery, we found a 5-gallon specimen. I was excited to plant it and watch it grow. I planted the beargrass, and it was growing well when suddenly the plant died. How could that be? Out here, the most likely suspect is the Botta's pocket gopher. These creatures are only 5 to 7 inches long and weigh less than a pound. This gopher is a vegetarian and is covered with light brown fur. Locally, gophers filled an ecological gap that used to be fulfilled by prairie dogs. The local extinction of prairie dogs came after unlimited bounties were placed on them. The spread of gophers has helped aerate the soil and allow for greater nutrient mix. Still, they are destructive when it comes to gardens. The underground rodent can often be seen shoveling dirt out from one of its checkerboard of holes. This one dug under the beargrass and ate through the entire root system. Just like any rodent, their two front incisor teeth grow throughout their life, and they must know how to keep their teeth from growing too long. If allowed to grow without constant gnawing, they would eventually not be able to eat and would perish. Author Edmund Yeager described an amusing encounter with a gopher in the desert. One spring, he laid out his bedroll in the middle of a group of wildflowers. After a fitful sleep, he awoke at dawn and peeked out from his bedroll. Nearby, he noticed a stalk of flowering lupine moving slightly, although there was no breeze. His interest was piqued as the stalk began to violently move back and forth and slowly dove underground. Another nearby stalk began to wave and began to fall to one side before disappearing underground. Yeager knew the only magician in this natural magic act would be the gopher. Then, close by, he began to see the earth move and heave. A homely whiskered head with beady eyes poked up out of the ground. It disappeared under the ground, and dirt once again was shoved up and out. Ager observed that the gopher used his front paws to push up and forward. I have also seen them use only their heads as a way to shovel the dirt, and observed another gopher use its front teeth like a bulldozer. In my unfortunate case, the offending gopher was actively working on its tunnels during an unusual time of year. They usually start to construct an underground home very early in the spring, or later after the monsoons have begun in summer, or during the winter months, depending on rainfall. This gopher decided that the recently watered roots would suit him just fine for a meal. It was an adult gopher because of the telltale mound of dirt they leave from their excavation. Young springtime gophers first appear above ground digging their own tunnels. They are only about 1/3 as large as the adults. They appear popping out of their holes starting in late April. The young ones do not make a mound of dirt. Instead, there is a 2 to 4 inch horizontal hole in the ground. The young are miniature versions of the adults, but behave differently. Instead of eating roots and things below the ground, we have observed them take downed and dried stalks of weeds, such as mustard weed, from the ground and drag those quickly underground. One young gopher grabbed an 18-inch long stalk and quickly dived with it into the burrow. So ends this chapter. See you at the next one. So long.